Всем доброго дня. Меня зовут Скоробогатов Александр, и я хочу представить своих коллег Джанлуиджи Вигано, Марко Гесснер и Маурицио Феличи. Это наши эксперты из компании Vertica, которые сегодня расскажут, сделают презентацию по поводу, как использовать множество источников данных в более богатом анализе. Итак, Gianluigi, Marco, Maurizio, I want to hello you. And how are you?
Not too bad.
Is everything fine?
Yes.
Fine, thanks.
Can you hear
Very
me all
good,
right?
thank you.
Yeah, I'm fine.
Yeah. I hope the weather is much better in your place of your live, and because in Moscow it's really autumn.
Well, it's roughly autumn here as well. It's
Same here.
it was really cold yesterday and the day before.
Mhm.
So yeah, could have been better, but it's the time of year.
We are waiting. Yeah. It's winter coming, and we are waiting for the winter. But let's start with the presentation. We'll start. Yeah.
I'm the
Marco,
one
stage
who's
is for
supposed
you.
to start.
Mhm.
So the topic is how to bring advanced analytics to hybrid data storage with Vertica. Let's see if I have the control. It looked like I had one, but I have to check. I have a laser pointer that works, but I cannot move. Oh, it works like this. Okay. So it's all about data being scattered all over the place in many forms. You may store a customer table in the main database while storing a sales table in another SQL database, and you may be keeping the shop sales data available in various object storage locations distributed all over the place on-prem and in the cloud. And you want to see and use all that scattered input to produce one consolidated document. The input can be physically stored in different places, from cloud to on-prem to a mixed environment. The data format can be stored in a variety of formats, from a simple CSV file to a database table. And the user needs one single holistic views for all available data, no matter from where and in which form, and accessing and manipulating it, all with the same uniform method, one and the same toolbox. And the richer the toolbox, the better. In the following slides and the following hour, Maurizio, Gigi, and I will shed some light on how to create that unified overall view to the data. We will shortly touch alternatives, compare both the versatility of the alternatives available and the mechanisms for accessing that disparate data. And finally, we will shed a few words why we are convinced that Vertica excels both at speed and versatility, richness in data processing capabilities. I'll continue with a short reminder of what Vertica is, how it has evolved in data architecture since its conception in 2005, and with a few thoughts on the Vertica toolbox compared to what is available out there, plus some thoughts on when to keep the data external or promote it to internal table. Then Gigi will chime in with considerations on how to map external data to the Vertica engine, the various built-in mechanisms to perform that task, how to use them, also how to deal with complex data like arrays and nested structures, and also a few performance considerations on that. And finally, Maurizio will conclude with the presentation of something we're all pretty proud of, a special type of external table that he greatly developed himself for Vertica. So you have everything out of the mouth of the horse himself. He has created an internal mechanism that sets us apart from our competitors in speeding up internal data in external table data access by orders of magnitude while remaining in the SQL standard. So let me start with a few words of what is Vertica. It is three things. It is an SQL-based data warehouse platform. That's what it started as, which can query data at still unmatched speed. It is an analytics and machine learning platform in which users can create, train, and deploy machine learning models. And it is now a query engine that can query data from wherever it is residing. Examples: S3, Google Cloud Platform, and Hadoop. We have seen an evolution of compute and storage with the upcoming of big data. The tight integration between compute and storage that was adopted by shared nothing MPP architectures generally provides very good performance, resilience, and if one node fails, the system will continue to work. And on the other hand, scaling up and down the system can be cumbersome because adding nodes implicitly requires redistributing the data differently. If you have 4 nodes, every one has 25% of the complete data. If you have 5 nodes, every node has 25% of the data, and you have to distribute the data differently. With the upcoming of cloud computing, the great idea of having the possibility to separate storage from the computing power was suddenly possible. You could basically add or remove nodes as you liked, and you paid a little price because you have to pull the data from communal storage to the compute layer before being able to process it. But platforms like Vertica go around that problem by caching the part that they need for a query locally in local storage, and then basically behaving as if it was local storage. And then there is a third way, namely compute-only solutions, which basically ignore the storage layer and leave the data under the responsibility of the source systems. The flexibility of this solution is higher, but performance is considerably penalized because you basically almost always have to pull the data up to that something else, to that compute layer, to be able to join it together or to be able to make some sense out of it. Data virtualization tools also have the handicap that they can only push down to the database the capabilities that the data virtualization tool knows that it is supported by the underlying platform. And if you go to many platforms, it has to know an awful lot to find out what the others do support. It's true that you can add your own customizations to such a data virtualization tool, but then you have to code for each for each platform that you basically push down the information, the request to, how to translate it. So it's not really a very handy way of doing it. And in the cloud, we also have cloud-only databases that claim that they are reaching out to other databases, but you suddenly find out that these cloud-only databases really don't do it in a very efficient manner. And to make things worse, they don't even have the capability of reaching out to an external SQL database. Yeah, Vertica is actually the only platform that offers all these possible scenarios, a smooth migration and integration path, the possibility to create hybrid solutions, for example, sensitive data on local storage and less sensitive data in the cloud. Cloud-only databases actually have a problem with local data privacy laws because of that. Then we have unmatched database functionality. I'm going to come to that. And really unmatched performance. Vertica provides an extremely powerful engine. When we say unmatched performance, McKnight Consulting ran a test using the big data benchmark that you can find out on the internet, and McKnight compared Vertica with two other cloud databases. So Vertica on the cloud, we can be on the cloud and on premises, as we said. So a cloud version of Vertica with two famous cloud-only databases, and we were 2.5 times faster than the runner-up, than number 2, and we were 3 times less expensive when we looked at the cost that was around it. So Vertica, with that power, we can keep the data on local storage, on private clouds, on public clouds. We can use a variety of storage components to keep its efficient, fast read optimized storage format. We can use other standard formats, Parquet, ORG, CSV, JSON, and differently from other solutions, we can connect directly to external databases. That's a part of Maurizio. This means you can run federated queries, joining, for example, a Vertica managed internal table with, let's say, a SQL Server, an Oracle table, just by connecting via an ODBC interface. And if that is not enough, we have a powerful API framework that lets you define your own formats and interfaces. This slide is one that people like Maurizio, Gigi, and I, and others that have a similar job, and Sasha as well, Alexander, keep updating. We go to the official websites of all possible databases and count the number of functions that they have to offer in their SQL. The gap is what the business needs, and this is basically what the database offers. And the data, of course, there will always be a gap, because you can be as good as you want. You can never foresee a new business need that a new business might have. So there will always be a gap. The trick is to keep the gap as small as possible. That's mind the gap. A few weeks ago, we added the first data virtualization tool to this equation, and it scores one function less than a very mature MPP database that runs on-prem. So, and you see that the median of this is roughly something between 200 and 300. This is an attempt to show the categories of functions that Vertica has to offer. We group those in categories. And if we go to, this is basically what we did with our categories and functions, and we then went to compare them to, in this specific case, the data virtualization tool that was orange in the previous slide. Now you can argue that something that Vertica meta functions shouldn't count because they live and die with Vertica. And you can also argue that system information functions shouldn't matter because it is a data virtualization tool and that has no system to keep information about. But the rest does count. And even in the aggregate functions, the virtualization tool did have a few, but not quite as much as Vertica. And in the analytic functions, we had the same. So the effect of an external table, the thing that you get with the Vertica external table layer is that you can map any data format so that it looks like an SQL table, so it is tabular. You can get it from everywhere, and you can treat it as if it were a normal table. And all external tables are created with an SQL command that begins with create external table, schema name, table name, the definition, and how to get to the data with as copy. All right, so when does it make sense to use external tables and when do you remain internal? The default and obviously the fastest is reading from internal tables. Scan them with internal onboard means. You also have the possibilities that the Vertica optimizer actually has built in, so that you basically, if you know that a filter that is used on one table is also used on the table that is joined, because, for example, the timestamp filter is the same, Vertica is clever enough to pass that information behind the scenes fully automatically to the scan of the table that is joined. We call that side information passing. And we have other optimizer gems, as we call them, that make life easy there. With external tables, you get a certain penalization. We do, however, in the case of the SQL external table, we actually have a mechanism that Maurizio will explain, where we have some sort of side information passing, as I explained it before, where we actually can exploit the filter and the pruning pushdown mechanisms, and actually even exploit the power of the optimizer, if it is good, of the other database. In the case of more file-based sources like Parquet and Orc, we can still exploit the filtering mechanisms of Parquet and Orc, which is column pruning and partition pruning, and sometimes push down of the where condition. So there I would keep them external. And the third external table type is a bit more complex. If it is just a CSV file, if you just have a JSON file or similar, you cannot push down anything. You have to read everything, push it into Vertica, and then only there filter it away and prune columns away. The suggestion is make it internal, create the table, and copy the data in. The reason why we want to pull data into Vertica, well, in the case of Vertica, you have the default is just like this. You have the Vertica database and the big bunch of functionalities that Vertica has to offer. You can get quite some similar ways of dealing with data using the SQL engine of an external database, or something like Hive, which is also SQL based. But even if the crosses won't be as many as in the case of the external virtualization tool, you will find these crosses, these red St. Andrews crosses, here and there. And you will have a SQL Server, Oracle, Teradata dialect here, and another dialect in Hive. You can make that a little better with the data virtualization tool, where you have one and the same dialect of SQL. It will always behave the same way and pull the data for you to the data virtualization tool, but with the smaller functionality and only what it ever can push down to the others, and it knows how to push down. If you use the external table layer of Vertica, you can do more with an external table than this one using just the Vertica engine, and you can join the data here using internal side information passing to even be faster to pull the data in and make joins on the fly. That's roughly my part, and it's Gigi's turn. Thanks for listening to my part, people.
I think that you have to take a question.
Do I have to take a question, or do we take it at the end?
Let's take it in the end. I think it would be much easier to us to discuss, because we can group and combine some questions.
Now, let's make sure that Gigi has the command of everything, and we can take it from there.
Mm-hmm.
Yes, I'm waiting to have the control. May I have the control? No,
Okay, I had muted myself too early. Sorry.
Danny, I have to take the controls.
You can move the laser pointer at least. I didn't move it. Gigi?
No, I haven't the control. Okay, thank you. Yes. Okay, thank you. Okay, thank you, Marco. So as from Marco, we practically have 4 possible repositories to address with the external table. These are the external databases, the object store, the POSIX file system, and the HDFS. And about the file types, we can divide them in 3 categories. So we can have the database tables, the flat file that usually they are stored here, and the Parquet or ORC, where the data they are organized in tabular format. So what's happened when we access to the external table? You already saw the SQL statement. This is the SQL statement that we will explore it later. So what is important is that when we run this statement, practically we create an external table, and it means that we only create an entry into the catalog of the database definition. So there is no data movement. There is only the creation, the table creation. We can create an external table with any definition, even if it doesn't match with the content of the external table. So practically, even if the external file doesn't exist. The definition will be used when we access to this table, and in that case, you will have an error if the table definition doesn't match. Okay. When we access to the to the shared repository, practically Vertica use the apportioned loads. What does it mean? Practically, the apportioned loads break the input in portion and assign them to the execution nodes for loading. And each node start parsing the external data from the offset it's assigned. And for Parquet and ORC, in Vertical there is the native CERD, The goal of the native server is to push the query execution closer to the data, okay, in order to reduce the data read and the transmission of the data to Vertica. And then there is the predicate, the predicate is pushed down in order to evaluate each stripe or row group at the source. And the partition pruning is used to skip subdirectories that doesn't satisfy the predicate. For external databases, we have the federated queries approach that so we'll be exploring the next session from Maurizio, that and he will go in details. Okay, then how to create the external table. As said, okay, we have to define the table, and we have to define the structure of the table, like for a normal table. The difference is that here we specify that the table is external, and here we have exactly to describe the table. Then we have to add the location of the table. We mentioned that the table can be stored in different places. And lastly, okay, we have to define the type of the table. So it can be one of these, Parquet, Org, JSON, any table. Okay. But okay, you can say, okay, you told us that we have to define the column, but what about so if the external table is is made by a complex structure? So how to describe the columns for a table with a complex structure also? And you have to remember that when we define the external table, there is no match, so there is no control about the the effective structure of the external data. So it risks to be an exhausting process, because every time you create a table, then you have to check and so on. And here Vertica help here. Okay. So in Vertica there is the Vertica function that infer external table DDL, and that comes to help in this case. What it does, okay? Practically, it inspects a file in Parquet or ORC format and return the create statement. Create external table as a copy statement. So the results that can be used to read the file. It handles most of the data type found in the ORC Parquet file, including the complex data type. There are some parameters that you pass that practically they are the location and the name of the external data, and the format and the table name that you wanted to have in the create external table statement. Okay. So eventually, if something is not recognized or it is ambiguous, Vertica by default define the data type as var binary. This is a definition that allows to read in any case the file later with the function that are provided internally to Vertica. Lastly, there is the partition. So partitioning column, they are also recognized, but the Parquet and ORC they don't contain sufficient information to define the partitioning column, so this is defined as data type unknown. Okay, and obviously it has to be manually adjusted. This is for the table. Note that for the struct, Vertica uses the row. Row is the data type used to define the structure. For the others, because here we are speaking about Parquet and ORC, for the CSV, delimited, and so on, there is the D2LE. That is the tool that Marco built. You can find it on GitHub. Okay. And practically it works in the same way like the inferred external table. Lastly, for all the, let me say, the other semi-structured data type for JSON, CF, Avro, and so on, Vertica has some built-in parsers that you can use. And to use this parser, you have to specify here in the table definition the with parser and then the parser name or parser type. Okay, but okay, Vertica also has some native complex data types, so that you can use, to manage Vertica internal table. Okay, we already talk about the row, and then there are the array and set that are the one-dimensional arrays. Okay, containing native Vertica data type. So in details, we have practically the array that is a one-dimension collection of elements. Okay, so practically it contains the elements as they are inserted. The set is, let me say, a particular array. This is also a one-dimensional array, but it contains an ordered collection of elements. Okay, where the duplicate data are removed. Okay, this is a good implementation that you can use to optimize the lookup. So where you are not interested in exact sequence of the value, but only on certain values, you can use the set. Obviously, it is possible to cast the array and set, and with this operation, practically you remove all the duplicate values and you order, the content of the array. Just to give you an example, if we insert this sequence of values, okay, into the array and set, so into the array, and then we cast the array to the set, these are the results. So practically for the array, you have exactly what you inserted, and for the set, you have, the sequence ordered and without the duplicated values. Note that in one of the definition here, we defined this is called the bound of the array. So 10, it means that the array can have at maximum a certain number of elements. But here we will explore the bound in WhatsApp. Okay. So why we define the bounded array? So the array they are used in column definition can be either bounded or unbounded. So bounded array, practically for the bounded array, we must specify a maximum number of elements that the array can contain. Unbounded arrays can specify a maximum binary size for the array. Or if we don't specify that, practically Vertica takes the standard value of the database parameter. And this is useful. The bound option using the array, because practically during the query processing, Vertica always reserve the maximum memory needed for the column based on the element count or the binary size. If the size is much larger than your data, okay, then your data actually require setting one of these limits can improve the query performances, because it reduces the amount of memory that must be reserved for the column. And here you have the examples. Where is okay? Sorry, okay. If we define a table with an unbounded array, an array with a maximum number of elements, and an array with a maximum number of bytes, as you can see, practically you have different size for each of the options. Okay, and this default parameters is obviously default that can be tuned. Okay, so how this is compared with the others? Okay, here in this comparison, practically we consider the best available option for the cloud. Okay, so the cloud solution and the software as a service solution. For the set, okay, in the popular cloud solution, practically we have the array that is ordered, so it is a mix between array and set. And it has some limitation because it doesn't remove the duplication. For the full support for null and empty arrays, the cloud solution practically allows you to have null elements, but it doesn't manage the null arrays. It is different, okay? And about the bounded arrays, that is a very useful feature in order to save the resources and speed up the execution. None of the possible solutions, so the cloud, the SaaS or the Spark, they have this option. So how this this native data type they perform against one to each other, okay? So let's see, because practically we took a real customer case, and the customer has a wide big flat table containing a list of integer in a test like this. So practically there is a comma separated list of integer value. And the query has two filters, okay? One is temporary time frame, and the other one is the list of the integer that we wanted to select. So the scope of the test is to check out, optimize the table structure, so the field type, in order to optimize the query elapsed. For the test, we remove the temporary filter because it has no influence, okay? Because we use the same field type on all the tests. So to prepare the environment, practically we created a table with the three options in order to store the text with the integer. So we use the varchar column, the array, and the set, okay? And we use the bounded definition here. And then we generate 100 million rows, inserting random values into the text field, okay? Each field text will contain a random number of elements with a value from minus 1 million to plus 2 millions, okay? And here there are the results. So practically the query is counting the number of occurrences for a specific value. And note that for the array and the set, we have to search for both the positive and the negative value, because in the case of varchar it is a string search, and here we are searching for integer, okay? The results shows that the array and set, they are 18 times faster than the varchar option. About the storage, okay? About the storage, practically storage used, the array needs more or less 30% less storage than the varchar, okay? So here we are measuring the space used by each option. The sets, here it's not visible, but practically the sets needs 1% less storage than the array. But remember, the sets is influenced by the redundancy, and here we are generating random values, so practically each sets contains about 3 millions of random values. If we decrease, the number of random value generated to 300, with the set, we are using more or less half of the space used by the array. Then we run another test, okay? In order to compare, because previously we used the varchar, here we compare the case in where we flatten the arrays, okay? So practically we created 3 tables, and in one table we replicate the users. So here we have 1 million users, each of them has 1,000 distinct search words, okay? So practically the first table has the flatter structure of this user and words, and then we created the other 2 tables with the array and the set. About the queries, okay, we have 2 queries. The first query that count the search words for each user, and the second query that practically find a user with this, that uses specific words. And here there are the results. So the results shows that for the count, okay, the array is more or less 5 times faster than the varchar, and while on the other side the set is 6 times faster, so more or less the same results. In find, even here the array is 2 times faster than the flattening approach, and the set on the other side is 3 times faster. And here, I think that is the last slide. Yes, now there is Maurizio. Okay, I hand over to Maurizio that will explain. You remember that now we explored only the part of the external table approaching the flat file, the internal definition of the complex data type, and the ORC and Parquet. Now Maurizio will manage will explain you about the federated queries. To you, Maurizio.
Thank you, Gigi. Do I have control on the slides? Let me check. Yes, okay, thank you. Hello, everybody. My name is Maurizio Felici, and this last section, I'm going to talk you about what we call Vertica federated queries. I have 18 minutes available for this, so I will try to run. What are we talking about? So what is the scope? Mainly, the scope is to let users running queries in Vertica to access data that is on other databases. It could be Oracle, Teradata, any other database, okay? And what is the scope of this? Apart using data, so in this case, we are running a query in Vertica that will use data arriving from this DB1 database. I know that DB1 doesn't exist. I did pick one name, but you can replace DB1 with any other name. And you can run this query inside Vertica using the full power of the Vertica functions. We have seen that we have hundreds of functions inside Vertica using data that arrive from this DB1. Or maybe you might want to join a Vertica native table with a table that is on this Oracle, Teradata, or whatever database, okay? Imagine you have a large fact table in Vertica, and you want to create a join with a small dimension arriving from another database. You can do using these Vertica federated queries. We are using the very same infrastructure we use to access Parquet, Orc, CSV, and all the other files, which is the Vertica virtualization layer, the external table. So you can see the external table in Vertica like a sort of window to the external world, okay? So we have an example here. We have a Vertica table. We have a lot of fantasy, so we will call it V table, and this is a Vertica table. And then we have another table which is on other database, and as I said, we have a lot of fantasy. We will call this table O table, okay? We will access this O table that is running, let's say, Oracle, on this other database through the virtualization layer, which is the external table. And inside the Vertica engine, we will be able to run a select like this, where we join the two tables, the Vertica table and the other table, and we set this predicate here where the Vertica ID is less than 3. And this is the joining column, you see? ID is the joining column. This means that when we get the data, we will have to get the data from both sides of the join, of course. We will get only the ones having ID less than 3, because this is the predicate we have in our query. And this is true for both the data arriving from Vertica and the data arriving from the other database. This is a peculiar feature that we coded in Vertica. I'm going to explain how it works. I have 14 minutes available. How it works. So suppose that we have this other database, and we have here a table with ID and name, and then we have the Vertica table, which contains the columns ID and salary. Then we open the window to the external world. We create our external table that through the UDL will access the other table. You see the link? This is the link between the other table that is here and the E table that is the other side of the window inside Vertica. And when we run this query, we push down the predicate ID less than 3 on both sides. This is what we do. If you are curious, the UDL that you use here is actually open source. So you can have a look here. You see, I don't know if you can see my mouse, but at the very bottom there is a GitHub link, and this is what you can access in order to see how it works. I mean, the source code, the real source code. So what happens along the time axis? I'm going to see what happens along the time axis in both the Vertica database and the other database, okay? So at the beginning, let's say at time t0, we create the external table. So we open the window to the external world, and this window contains a select star from the other table, which is on the other database, okay? So this is what we do in Vertica. At this point in time, the only things that happen in Vertica is that we create a catalog entry for this table inside the Vertica catalog. Then what happens at T0 on the other database? Nothing. Absolutely nothing. I mean, the database can be shut down at T0 from the Vertica point of view. Makes no difference. Okay. Then at time T1, we run this select column 4, 5, and 6 from the external table, which is the one we created here, where column 1 is less than 3. Now we run the UDL. You have the link on the previous slide, and we run the copy to extract the data. At this point in time, this is the magic thing. The Vertica optimizer sends some hidden parameters, some hints to the UDL, telling the UDL, hey, listen, you don't have to get the whole table. You just have to retrieve column 4, 5, and 6, where column 1 is less than 3. So what the UDL does, thanks to these hints, is to rewrite the original query. You see, the original query was the red one here, select star from O table, and now is select C4, C5, and C6 from select star from O table, where C1 is less than 3. Now, after we run the query against the other database, we retrieve the data. We retrieve the data in block of rows to make this more efficient. There is a parameter you can use in order to configure how many rows we fetch at every fetch cycle. And that's all. Then at time T2, maybe we have another query. And well, we are short in time. We go through the same process. So we run the UDL. We will have new parameters which are different from the previous one, of course. And then we'll rewrite the query in a different way. We will execute the query on the external database, let's say Oracle. We'll retrieve our data, and we will return the data to as a result set to the client tool. Okay, so basically, if the table we have on the other database is as big as this one, and we are interested only in a small portion of the whole data. What we do is to retrieve this small portion. We bring the data out of the other database to Vertica, and then we use this data to run our Vertica query. This is something that has been created in version 10.1, if I remember well. The current Vertica version is Vertica 11. I guess 6 to 9 months old. Okay. So a few query conversion example. So I want to show how the query is converted. Suppose that we create an external table in Vertica. This is a catalog in Vertica where we write this information containing 4 columns: ID, name, gender, and birth date. And now in Vertica we run the select count star. What happens? Well, to run a count star, we don't need to bring all the columns from the other database. We need just one of those columns, and we will pick the ID, the integer, to run the query. All the others, we don't need them. We will replace them as a sort of placeholder with null, but there is no data arriving from the other database if it's not needed. Okay. A different one now is the same query as before, but where gender equal F. I want to count just the females. So what I do is to retrieve the column gender, and I have a predicate on the other database query where gender equal F, because the trick here is to retrieve and move as few bytes as possible. We know that the bottleneck here will be the network between the two databases, so we want to pick only the data that we really need. And this is something more complex. Here we have a join. The join is in the column ID, so we have to retrieve from the other database not just the name, but also the ID, because it's going to be used in the join. So the select for the other database will be select ID name. Okay. I hope this is not confusing. Basically, we want to retrieve only the data we need to run a specific query from the other side. There are some other implemented features, like, for example, some conversions. Suppose that you write the SQL and you are used to use the Vertica syntax. So, for example, you can shorten your like with tilde, or you can use a syntax like this, which is equivalent to something like this, or you use this, for example, colon, you can say the data type to run a cast without writing cast, open parentheses, blah, blah. And you can write colon, integer or varchar or whatever, and we replace this syntax, which is Vertica specific, to standard SQL in these cases. As I said, there are several parameters you can configure, and you also have the possibility to switch on and off some parameters. For example, one of the parameters that a customer asked us to add is to rewrite entirely the original query. So the original query maybe was a select star from O table. You know what? Forget it. I want to rewrite completely the query without rewriting, regenerating the external table. You can do using this parameter, or you can, well, switch on and off rows and column filtering. By default, both are true. So we do filter both columns and rows, okay? There are some other databases that say they do something similar. By intention, I won't use any name here. So you will see database 1, database 2, etc. This is just to tell you what, in our opinion, you have to pay attention to. And you have to pay attention basically to the possibility to push down the predicates on the other side and the usability. You see some example. There is this popular cloud-only database number 1, no names. How it works, they run the query on the external database, step 1. Then they export all the result set and they write this result set into an S3 bucket. Can you imagine? Then they go back to the original database, the popular cloud-only database, and they reread all the data that has been extracted and written to S3 again. And then they run the query. Well, come on. I mean, I don't have to add anything. When we run this query in Vertica, we never, ever land a single byte to disk, okay? We get the data, we move over the network, everything happens in memory, and then we run our join or whatever. Popular cloud database number 2. They also claim they have something similar, but unfortunately, they can run these federated queries only against 2 databases, which are MySQL and Postgres. So you will say, what about my Oracle instance? What about my Teradata system? Well, forget it. You can only run federated queries against MySQL and Postgres. And I mean, just imagine you have to write, I don't even want to comment. You remember the query that we wrote previously? Select from this table or table using ID in the joining column. It was plain, absolutely standard SQL. Whatever you run on top of an external table in Vertica is plain SQL, and you can access Parquet, Oracle, Teradata, or whatever. Look the syntax, and I mean, I will avoid any comment also because I have only 2 minutes. And they map data type at runtime, so you can imagine how fast they are. Others are, well, I will skip this, even more primitive. Some others pretend to have an external table created in their database, which has the very same column names that you have in the other database. I mean, come on, and no predicate pushed down. So, conclusions. Vertica was already able to access data in different storage locations since version 8 something, if I remember well, so a lot of time ago. Now we are able to access data managed in this since version 10.1. We are able to manage data from other databases in a very efficient way. And remember that all the queries are executed in Vertica. I have here just, I don't want to mention the customer name, but this is something, just a couple of statements that we received from certain customers that are already using these features. As I said, this is an additional package that is open source, and you have the link in one of the previous slides. So feel free to grab it and test it. And I have closed, and we still have 30 seconds in this slot for any questions. Here you have the link while waiting for the questions, where you can download the Vertica Community Edition for free up to 1 terabyte and 3 nodes, and you can play on your own.
I think that we have only time to invite our guests to discussion session. And let's jump to Zoom session to discuss and to look for the answers to the questions.